I hope everyone's having a great evening. I'm Mr. Ish. Thank you for joining me for this video. We're looking here at a good relationship video. In this video, we have to relate the Pythagorean trigonometric identity and the cofunction identities in a meaningful way. We are talking here everything with regards to sine and cosine. What's the Pythagorean identity? The main, most important identity of trigonometry, the sine square x or theta plus cosine square x or theta is equal to 1. This right here is the Pythagorean identity of trigonometry involving sine and cosine. What are the cofunction identities of sine and cosine? You know, sine of any angle is equal to cosine of its complement. Two angles are complement if they add up to 90 degrees. Likewise, cosine of any angle is equal to sine of its complement. And that right there is a very useful identity. How can we relate these to each other? Well, you can do so one by one utilizing the definition of each, which I've boxed. Look right over here and imagine these x's have been converted to thetas because theta or x is equivalent in terms of what we're doing here. Sine square theta plus cosine square theta is equal to 1. If sine theta is equal to cosine 90 minus theta, you would plug cosine 90 minus theta right in here because that represents sine theta. You do cosine 90 minus theta and you have all of this in terms of square plus cosine square theta is equal to 1. We're doing this and then we'll do the next. You would open this up using the sum formula or the sum and difference formula, trigonometric identities for cosine. You know, when you open this up, you'll have cosine 90 cosine theta plus sine 90 sine theta. All of this is under a square plus cosine square theta is equal to 1. Remember, the sum and difference formula for cosine x minus y would be cosine x cosine y plus sine x sine y. You have to remember those trigonometric identities. Open this up. Cosine 90 is a 0, all of the zeros out, but sine 90 is a 1. 1 multiplies with the sine theta, you retain the sine theta. You'll have a sine square theta plus cosine square theta is equal to 1, and we know indeed that is true, so that has been done. Now let's look at the next one. I'll erase this because you've seen this. We'll look at this one now. Cosine theta can be substituted for sine 90 minus theta. We're looking here at a sine square theta plus you have a sine 90 minus theta. This right here represents your cosine square component, and now you have to open this. This is sine x minus y, which would be sine x cosine y minus sine y cosine x. You have to remember these identities. When you open this up, you have to remember that identity. You'd have a sine 90 cosine theta minus sine theta cosine 90. All of this is under a square is equal to 1. Cosine 90 is a 0, all of the zeros out, but sine 90 is a 1. It retains the cosine component very well. You have a sine square theta plus cosine square theta is equal to 1, and this has been shown to be true. This right here is an excellent way for you to relate the two identities in a very meaningful way, and this is an exercise you should remember. Before I end this video, I want you to very well remember this and revise this one. Sine x and y in terms of the plus and the minus, this right here would be sine x cosine y plus sine y cosine x. Here you will have a sine x cosine y minus sine y cosine x. Likewise, these are what you have to know for cosine x minus y and cosine x plus y. These will come very frequently in calculus if you ever go into calculus. This one right here would be cosine x cosine y, but the minus here will become a plus. You'll have a sine x sine y. Here the plus will become a minus. Cosine x cosine y minus sine x sine y. These four identities you should know because they kind of came into what we were looking at, and that's all I wanted to present you. This, how you can relate the Pythagorean identity to the cofunction identities. They very well work together. Thank you for watching. Have a nice day.